us see what is meant by conductors and insulators. On the basis of resistance, substances are divided as conductors and insulators. Those substances which have very low electrical resistance are called conductors. For example, silver, copper, aluminium are good conductors. Those substances which have infinitely high electrical resistance are called insulators. Rubber, wood, glass are good insulators. Ohm's law. The electric current flowing in a metallic conductor is directly proportional to the potential difference across its terminals, provided physical conditions of the conductor such as length, area of cross-section, temperature, and material remain constant. If I is the current and V is the potential difference across the ends of a conductor, then V is directly proportional to I. Therefore, V upon I is equal to R. Therefore, V is equal to IR. R is the resistance which is constant for given conductors. The SI unit of resistance is ohm. 1 ohm resistance. If 1 ampere current flows through the conductor and 1 volt potential difference is applied across it, then its resistance is 1 ohm. 1 ohm is equal to 1 volt upon 1 ampere. A German physicist, Georg Simon Ohm, 1787 to 1854, stated the law which is used to calculate resistance in electrical circuit. The unit of resistance, ohm, is used in his honor. Students, you try this activity and note the observations. Make the arrangement as shown. Take the wires of equal lengths and thickness made of different materials like copper, aluminium, and nichrome. Join the wires one by one in gap AB. Plug the key and then calculate the resistance of each wire using Ohm's law by measuring the potential and current. What is resistivity? Resistance R of a conductor depends on the length L and area of cross-section A of the conductor. R is directly proportional to L and R is inversely proportional to A. Therefore, R is equal to RHO into L upon A, where RHO is called resistivity of the conductor. It is also called as specific resistance. If we put L is equal to 1 meter and A is equal to 1 meter square, then R is equal to RHO. Thus, resistivity of a conductor is defined as the resistance of a conductor of unit length and unit area of cross-section. The SI unit of resistivity is ohm meter. Resistivity is the characteristic property of material. It is different for different materials. Table shows the resistivity of conductors, alloys, and insulators at 20 degrees Celsius. Observe the figure 4.10 and answer the question. The figure shows 3 cylindrical copper conductors along with their cross-sectional areas and lengths. Compare them according to the current through them if the same potential difference V is applied across their lengths. Let us look at the activity. Take a 9-volt battery and a small torch bulb and connecting wires. Take 2 pieces of nichrome wire. Join the wires as shown and observe the intensity of the bulb. Now join the wires as shown. Observe the brightness of bulb. The bulb glows with more brightness in second arrangement than first. Let us look at the resistance of a system of resistors. In various electrical gadgets, we often use resistors in various combinations. Ohm's law can be applied to combination of resistors. There are two methods of joining the resistors together. They are 1. Resistors in series and 2. Resistors in parallel. Make the arrangement of resistors as shown. This figure shows an electrical circuit in which these resistors having resistances R1, R2 and R3 respectively are joined end to end. Here the resistors are said to be connected in series. In series combination, same current flows through each resistance. This figure shows a combination of resistors in which these resistors are connected together between points C and D. Here, the resistors are said to be connected in parallel. Potential difference across each resistance is same. Let us study in detail about resistors in series. As shown in the figure, suppose I is the current and V is the PD across points C and D. R1, R2 and R3 are the three resistors connected in series between points C and D. Then Rs is the effective resistance in a circuit and V1, V2 and V3 are the potentials across the three resistors such that V is equal to V1 plus V2 plus V3. Let us mark this as statement 1. But using Ohm's law, total potential difference V is equal to IRS and V1 is equal to IR1, V2 is equal to IR2 and V3 is equal to IR3. Substituting these values in equation number 1, we get IRS is equal to IR1 plus IR2 plus IR3. Therefore, Rs is equal to R1 plus R2 plus R3. For n number of resistors connected in series, we get Rs is equal to R1 plus R2 plus R3 plus R4 up to Rn. If the resistors are connected in series, then in a circuit, the current is the same in every part of the circuit. The resistance of the combination of resistors is equal to the sum of the individual resistors. The total voltage across the combination is equal to the sum of the voltage drop across the separate resistors. The effective resistance in a series combination is greater than the individual resistances. This combination is used to increase resistance in a circuit. Now let us study about resistors in parallel. Let three resistors R1, R2 and R3 be connected in parallel between points C and D. I1, I2 and I3 are the currents passing through R1, R2 and R3 respectively. Let V be the potential difference between points C and D. The current I will be given by I is equal to I1 plus I2 plus I3. Let us mark this as statement 1. Let Rp be the effective resistance in the circuit. Using Ohm's law, we get I1 is equal to V upon R1, I2 is equal to V upon R2, I3 is equal to V upon R3 and Is is equal to V upon Rp. Putting these values in equation 1, we get V upon Rp is equal to V upon R1, V upon R2, V upon R3. Therefore, 1 upon Rp is equal to 1 upon R1, 1 upon R2, 1 upon R3. For n number of resistors connected in parallel, we get 1 upon Rp is equal to 1 upon R1, 1 upon R2, up to 1 upon Rn. If the resistors are connected in parallel, then the sum of reciprocals of the individual resistance is equal to the reciprocal of equivalent resistor. The currents in various resistors are inversely proportional to the resistances. Higher the resistance, lower is the current through it. However, the total current is the sum of the currents flowing in the different branches. The voltage across each resistor is same. The effective resistance of the combination is less than the individual resistance in the combination. This combination is used to decrease resistance in the circuit. Think, in which arrangement the bulb will be brighter? Why? The bulb will be brighter in parallel arrangement. In parallel arrangement, the effective resistance is less and current more. Therefore, the bulb glows more brightly in parallel arrangement.